right, gang, this is part 3 of our Introduction to Environmental Economics. So we've talked about tools in the economist's toolkit that they use. We talked about A, market pricing, and so you remember us talking about letting water be priced by the market rather than having a government subsidized price that's artificially low. We talked about B, private property rights. And so we talked about property rights setting the right incentives because they force you to internalize any damage you do to the property, but also if you do something good to the property, you internalize the benefits that you would receive. We're moving on to the third topic, C, incentives. And specifically, we're going to talk about both subsidies and taxes used to set incentives for people. So let's start with subsidies. When we talk about subsidies, we talk about a form of financial assistance paid to a business or an economic sector. So a form of financial assistance that's paid to a business or an economic sector. But we should probably also add into our notes that it could also be paid to an individual or a household. So for example, let's say that I buy a hybrid car and that hybrid car is subject to a subsidy. Well, that means I'm getting financial assistance to help defray the cost of this alternative fuel type of car, so this hybrid car. So it could go to me as a household. It's important that you understand how to graph a subsidy. So for right now, don't draw the second blue line with the subsidy. I want you to just draw your downward sloping demand curve and your upward sloping supply curve. Now, do you agree that in this graph right here, just before the subsidy, we have an equilibrium price P, because that's where the curves intersect, and it results in an output of quantity Q. So supply and demand intersect to give us price P and quantity Q. Now, if we want to subsidize, what that's going to do is increase supply, as you see, right? Supply has kind of shifted to the right. But it's important for you to understand that what actually has happened in this subsidy is that the supply curve has shifted literally downward. Do you see that orange arrow? That orange arrow is measuring the amount of the subsidy. Now, I've drawn it to be pointed downward, not to the left or right, not at a diagonal, because subsidies are a dollar figure. And on this graph, I only have 2 dimensions. The vertical axis captures price and the horizontal axis captures quantity. So if I'm trying to show a subsidy, which is a dollar amount, maybe it's $5 per unit, I have to measure it against the vertical axis. Hence, why I've drawn the arrow representing the subsidy to be vertical. If I were to draw it on the diagonal, then that would go across both P and Q, which would make no sense. If I drew it as a shift to the right, that would make no sense because then I'm measuring a quantity, and a subsidy is a dollar amount, not a measure of some number of units. So first thing is that the subsidy literally shifts the supply curve downward. So make sure you get that in your notes. But it does indeed look like an increase in supply. Now, let's look at the effect of the subsidy here. Do you agree that the subsidy has lowered price to P1? So what's one outcome from the subsidy? One outcome from the subsidy is that it lowers price. But here's my question to you. Did price go down by the same amount of the subsidy? Well, the subsidy, remember, is measured as the vertical distance between the 2 supply curves. So let's say that the subsidy is $4 here. Well, it looks to me like price only fell by $2. So when we subsidize, we're not necessarily passing that full cost on to consumers. It depends on the scenario. We'll talk more about that later. But what we do see is that the subsidy increased quantity from Q to Q1. Whatever we're talking about here, the subsidy has stimulated it. We're getting more of something that's good. So, as we just said, a subsidy is used to lower the cost of a desirable activity. So if something's good and we want more of it, we can use a subsidy to do that. And that's what we saw in the previous graph. Often subsidies are in the form of a tax credit. And I'm pointing this out because I don't want you to be confused if you're reading about something and it talks about a tax credit. A tax credit is really like a negative tax. Instead of you paying government, they're paying you. And so let's say there's a $2,000 tax credit for alternative fuel vehicles. Well, then the government's essentially paying me. A tax credit literally gives you a dollar for dollar offset against your taxes. So let's say I owe $20,000 in taxes, but I have $5,000 in tax credits. What that means is I really only have to pay $15,000. Okay? So a tax credit is a form of a subsidy, but not all subsidies are tax credits. So please be clear about that. Here's an example. Let's say a solar-powered roof costs $30,000, but there's a tax credit of $9,000. So you pay for this solar-powered roof, $30,000. Then when you're doing your tax return, you get to deduct the tax credit of $9,000 from what you owe. And so the timing of it might be different, right? I might have bought the roof earlier and now I'm doing my tax return, but in net, this is reducing my cost to $21,000. So this tax credit acts as a subsidy. And of course, the whole point of the subsidy is to increase the number of solar-powered roofs. So what do we do if we offer a $9,000 tax credit, but people aren't responding to that? They're just not getting more roofs. What are our options here? Well, hopefully you're thinking maybe we try a bigger tax credit. So if $9,000 isn't enough to change people's behavior, then maybe we try a $12,000 tax credit. Again, that would cost the government more money, and that's important to think about, that we've got to be able to pay for this because it's taxpayer money that we're spending here, but ultimately we want solar power roofs and we need to set a tax credit, i.e. a subsidy, that people will respond to. Now, we do see some subsidies. For example, there are subsidies for solar power for utility plants, but that's got to be something pretty costly, right? Remember, utility plants that are producing energy usually are burning coal. So moving to solar power can really have a great impact on the environment, but it's got to be an expensive technology. There's also subsidies for solar powered homes. That was the example we just talked about. There are subsidies for ethanol and alternative fuels, for biomass. If you aren't familiar with biomass, this is fuels that's made from plants and animal waste. And then there's also a subsidy for hybrid cars. Now, let's think about the hybrid car example for a second. We don't see a lot of hybrid cars, right? Well, what does that tell you? That maybe they're still pretty expensive, even with the subsidy. In other words, the subsidy's probably not big enough to get people to start driving hybrid cars. If we really want to see a lot of hybrid cars on the road, we're going to need to give a much bigger subsidy. We also probably need to address some of the constraints because it can be a little difficult to operate in a hybrid car, especially if you're driving long distances. Now let's talk about taxes. So the opposite of subsidies are taxes. Obviously, taxes are used to increase the cost associated with an undesirable activity. I want to make something that's bad for the environment more costly, and so a tax is a way to do that. If you understood the subsidy graph, you'll understand the tax graph. But again, let's start with drawing our downward sloping demand curve in blue and just focus on our original supply curve S1. All right, so does everyone agree, ignoring S2 because that's after our tax, just looking at demand in S1, we see an equilibrium price of P1 and a quantity of Q1. But a tax, remember it's a dollar figure, and so I have to measure it vertically because that's how we measure dollars, against the vertical axis. A tax literally shifts our supply curve vertically. Make sure you get that in your notes. And if I ask you to show me the tax or show me the subsidy, you have to measure it vertically. So the amount of tax is that vertical distance between S1 and S2. So after we've imposed the tax, we're at S2. Well, look what happened to price. Price to consumers went up by P2. But that increase in price from P1 to P2 is not exactly the full amount of the tax, right? We'll talk about that later, but make sure you understand how to read this graph. Price went from P1 to P2. So now whatever you're doing that harms the environment is going to cost you more. Now let's look at quantity. We do see quantity fell from Q1 to Q2. In this graph, we don't see a huge change in quantity. Because of the demand curve. Take a look at that demand curve for a second. That demand curve is drawn fairly vertical. So this is where your principles of microeconomics come in, and you're going to have to remember terms like inelastic and elastic. Well, this demand curve is drawn fairly inelastically. In other words, this demand curve is such that consumers are not that price responsive. So inelastic, not that price responsive. So they're going to pay this higher price and cut back a little bit, but not cut back a lot. So this might be something like gasoline. We can put a tax on gasoline and people might cut back a little bit, but remember, what makes the demand for gasoline inelastic? Because there's few substitutes. It's harder to carpool, we don't have mass transportation in most cities, and there's really nothing else I can put in my car other than gas. So we're a pretty gas-centric, car-centric society. But the tax did still reduce the quantity from Q1 to Q2. So that's a good outcome here. We see a lot of environmental taxes in Europe, and unfortunately we don't see a lot of environmental taxes in the United States. So European nations are much more willing to impose environmental taxes, and we live in a country that has been very, very hesitant to impose environmental taxes. Here's one example, the gasoline tax. Now, we do have a tax on gasoline, but this graph right here, albeit it's from 2005, so I really should update it, but the results aren't going to be that different. This is gasoline tax as a share of total price. Remember, gas is a global commodity, so the actual price of gas isn't going to be that different. It's the tax that they put on it that makes it different. So these are 23 OECD countries from 2005. And what is our takeaway from this graph? The United States has the second to lowest tax as a share of total price. Look at the United Kingdom, look at Germany, look at Netherlands, Sweden, France. They have really big taxes on their gasoline, and ours is really small. The only other country in 2005 that had a bigger tax was Mexico. So we're pretty hesitant to tax things like gas. So we have a very small gas tax relative to other countries. And the more important point is that it's not clear we can even call this an environmental tax. While we have a tax on gas, is it an environmental tax? Probably not. Remember, when we impose an environmental tax on something, it's because we're trying to help the environment. And we're going to do something good with that money, or at least not do something that hurts the environment with that money. So what do we do with the tax we collect on gas? Well, in the United States, our gas tax money is used to subsidize road construction. So think about that for a second. When we take the tax from gas and we use it to subsidize road construction, in other words, we're going to build more roads and we're going to repair roads, is that good for the environment or is that bad for the environment? Well, clearly this is bad because more roads mean more driving, right? So better roads, we have more drivers. More driving means more pollution. So while we do put taxes on gasoline, it's not an environmental tax. So people might respond to it, but we'll have a whole unit on environmental taxes. Let's talk about some examples of what we might consider to be actual environmental taxes. Well, take a look at Sweden. Sweden has a tax on carbon-based fuels. Now, they're not the only one, but we don't have a tax on carbon-based fuels. So think about it. If we had a tax on carbon-based fuels, then we would have a green tax at the gas pump. We would have a green tax on electricity. So Sweden has been very ambitious. This is a pretty sweeping, overwhelming tax, but they're not the only ones to have it. Another example we can find in France and Germany, they have a tax on water pollution, but then they take the money and they use it to build better water treatment plants, maybe that are kinder to the environment, that take less energy, that do a better job. So that might also be considered an environmental tax. Germany has a tax on fast food containers, trying to get people to not use them. It might give businesses an incentive to find some other alternatives other than kind of your typical styrofoam fast food containers. Ireland has a plastic bag tax. So again, what are they trying to do? They're trying to get people not to use plastic bags, and hopefully people stop using them. Toronto has a good example. A number of years ago, and I'm not going to show this video because it's not going to necessarily play well as I'm capturing this in my office, but they imposed a 5-cent plastic bag tax. And the person in this video is kind of complaining about the tax because he's saying, hey, instead of putting a 5-cent tax every time I use a plastic bag, why don't, if I don't use the plastic bag, you give me 5 cents off? So you go to the grocery store, and in Toronto, now if you want plastic bags, you have to pay 5 cents. Maybe it's higher now because this video is a few years old. But there'd be another way of doing it, a subsidy. Maybe instead you subsidize the person who brings their reusable bags. That would be another way to get at the same issue. One's a tax, one's a subsidy. It really just depends on who do you want to benefit. If you want the money to go to the government, then it would have to be a tax. If you want the money to go to the store for enforcing this, well then it would also have to be a tax. But if you want to benefit the person who's got to make the change, that grocery shopper, then give him a subsidy. So again, different ways to do it. They'll all have the same effect of lowering plastic bag use. When we look at environmental taxes in the United States, we see, unfortunately, very little. Here are some of the ones that I've found. We do have an environmental tax on dry cleaning. I'm assuming dry cleaning is very polluting. It's also something for which there's a reasonably inelastic demand, right? If you have dry clean only clothes, you own a suit, you can't put that in the washing machine. You're gonna have to send it to the dry cleaner. So it's inelastic, and it also probably has a lot of chemicals involved. So that might be a good place for environmental tax, assuming we're doing something good with the money. Tax on used tire disposal. When you go to buy a new tire, they take your old tire and they charge you a fee for disposal. Hopefully they're using that money to dispose of tires in a way that's a little more environmentally friendly. I know they've tested out trying to shred them, use them in asphalt, all kinds of things. So maybe some of that money is used to fund research. There's also a tax on noise pollution from airplanes. So again, that's a different form of pollution. We're not used to thinking of noise as pollution necessarily, but that tax is encouraging airports and different airlines to invest in things that reduce the amount of noise. For example, you might have airports that build these big walls surrounding the facility, and that tries to reduce some of the noise pollution. In our country, however, we have no real fossil fuel tax. In other words, we really don't have a carbon tax. Interestingly, it's been proposed by Congress, but it's failed to pass. And we're going to discuss this later this semester, but we just have not been very successful. When you think about it, in our very car-centric society in the United States and our limited mass transit, it would be hard to sell that, and it might be difficult for you to be that politician that says, hey, I got this great idea. We want to protect the environment. Let's have a real fossil fuel tax, because it's going to hit us in our anything involving oil. So any gas, for example, it's going to hit us in our electric bill. And so we're going to absorb a lot of costs, and there are going to be very limited ways that we might be able to limit the impact on us because we just don't have mass transit here. But more on that later. Finally, let's talk about cost-benefit analysis. That's the final tool in our economic toolkit, and we're not going to do a lot of cost-benefit analysis in this class. You could take a whole class on cost-benefit methodology, but we're going to refer to the idea of costs versus benefits. So the idea is that we need to estimate costs and we need to estimate benefits of an activity. So whatever activity that we're evaluating, we need to think about costs and benefits, and we need to actually measure them. And then we have a very simple rule. After we've measured the costs and we've measured the benefits, it's really simple. If benefits are greater than costs, then it's rational. If benefits are less than costs, then something is irrational. So we have this very simple rule for optimality. Benefits have to exceed costs. Now, I've left out the equal sign, so we need to really put that in the first statement, so my apologies. If benefits are greater than or equal to costs, then something is rational. In other words, if something creates benefits of $5 million, the cost is $5 million, that would be rational. So please go in and put the equal sign in the first statement. Benefits are greater than or equal to costs, then it is indeed rational. Now, often costs are market effects. And by market effects, I mean that they're measured already. So costs can generally be market effects, not always when we talk about environmental stuff. For example, it might be talking about the costs for firms who have to comply with a regulation. So let's say we're going to impose a new regulation for emissions. Well, costs for the firm can be measured. What kind of new technology are we going to need? We're going to have to upgrade equipment possibly, and we can measure those costs. That's what I mean by market effects. They're measured. It could be that we're talking about increased costs to consumers for goods and services. So now whatever's being produced in these factories that have this new technology, those costs are going to go up. Those products are going to cost more. Maybe we're talking about emission standards on automobiles, and after we implement this new technology, the cost of the car is going to be higher and consumers just have to pay more. So we could be talking about costs to firms when they comply with regulations. We might be talking about increased costs to consumers because goods and services get more expensive. It could be something like increased taxes. So a lot of these things can be measured. However, I do want to say that I should add something about costs can be non-market effects. If we're talking about the impact on an ecosystem, if we're talking about the impact on human health, those could be costs that aren't literally market effects. Benefits are usually non-market effects, and so benefits sometimes are harder to deal with. I can estimate costs, but often benefits are hard to measure. And so I need to somehow estimate them. So benefits are often non-market effects, meaning benefits are not easily estimated. So here are some examples. We might be talking about the impact on human health and maybe a change in life expectancy. Well, we lower emissions, we increase life expectancy, we make people healthier. I need to put a dollar figure on that. Or what about the second one? We do something and it benefits an endangered species. Again, that's not a market effect. We would need to somehow find a way to measure that. Third, we might have something that impacts habitats of species. And of course, that's going to help protect and promote species as well. But I have to put a dollar value on that. That's also not a market effect. Impact on the ecosystems, impact on water or air quality. You see where I'm going with this. That some things are already measured in dollars and cents. But do you agree with me? None of these things are measured in dollars and cents. So when I need to compare costs and benefits, I've got one measured in dollars and the other is number of years of life. I have to find a way to compare those. So to be able to do cost-benefit analysis, this requires us to put a dollar value on things. Not everyone likes that. This is very unpalatable to some people because they think, you know, it's pretty callous and cruel that I would put a dollar value on a species or a habitat or people. So maybe we're doing something that impacts the gray whale or it impacts the blue wolf, and now I've got to figure out, okay, what's the dollar value associated with having more gray whales or more blue wolves? Or maybe we're looking at, in the second example, pristine, undisturbed area, some land, and I need to put a dollar value on leaving that pristine. What if we're talking about something that impacts human health, maybe helps us live longer? I now have to put a dollar value on human life. See where I'm going with this? That's not so easy to do. But there are methodologies for doing this, and there are people whose entire jobs are to do these kinds of cost-benefit studies. But this raises ethical issues for some people. In other words, not everyone thinks that this is an ethical thing to do. For example, maybe some people feel that the value of nature can't be measured, that nature in and of itself has no price tag, that we can't possibly put any kind of dollar figure on it. But in reality, that's not true, because economists do have methods for estimating value. There's lots of different methods for estimating value. And so if you took a class on valuation methodology, you would learn about this. And there's some possibility I'm going to ask you to read just a little bit about valuation methodologies, keeping it very, very simple, because we don't want to get into learning about the methodology, but just understanding how we might go about this kind of thing. So let's wrap up. The goals of this lecture: explain what we mean by environmental economics. Hopefully now you understand the idea of environmental economics. 2, we have characterized some of the basic reasons for environmentalists versus economists. Hopefully you see that working together we can get a lot done, but we have different ways of thinking about things. We've also got to be able to talk to each other, so we need to have some common language. 3, we have discussed the basic premises of environmental economics, so you need to be familiar with those. 4, I've given you lots of real-world examples to illustrate where economics is relevant and can be applied to environmental issues. And then 5, if you remember, I asked you to watch a video so that you can understand normative and positive logic when discussing policy. And if you're watching this in some future semester, this might be something that I haven't asked you to do and you will do. But the bottom line, everyone needs to understand normative versus positive, and you need to understand that when we come to the table, some of the conversations we're going to have are normative. I think we should protect endangered species. Positive, we need to find efficient ways to do that create the biggest bang for the buck. Normative and positive. All right, we'll be doing more with that. If you have any questions, please let me know. Thanks for listening and have a fantastic day.